Ah, tricked you. You were checking your volume. Hey, man, that joke never gets old, man. Never gets old. Mr. Keys back to working. Okay, I didn't hold you out long enough. You probably didn't get a chance to even find looking for your volume switch. Today, kids, should be a relatively short lesson. Let's see, how many pages are we going here? Oh, I hit the wrong thing. Then I'll go back to that. Day 4 sucked. All right, let's go. What is going on? I want to be on day 8. There's day 8. Okay, day 8. Day 8. 1, 2, 3, 4, 8 pages. Okay, good. I'm just kidding. So here's what we're going to do. What we're going to do is we're going to factor. So let's factor this. X minus 9, X minus 5. Woo! Yay! Wait a second. That is an expression. Expressions can be rewritten, reorganized, simplified, but not solved. Now we're going to deal with an equation. Equations have this part. It has this equal sign. Not always equal to 0, but oftentimes. And those have to be solved. So when I do this one, that's not the answer. Over here, answer, done. Over here, I actually have to do a little bit more work. And the fact that I'm not seeing you guys write equal zeros is going to start becoming an issue. So now I am officially telling you that if you're solving an equation, it better have an equal sign in it, or your grade's going to equal 0. It's going to equal what it should be, a 0. So stop doing that. Otherwise, your grade will equal 0. Yes, that joke is not getting old. In this case, you finish solving by setting these equal to 0. What step am I skipping there? I'm skipping this step. X minus 9 equals 0. Add 9, Mr. Krause. Add 9. X equals 9. Do I think that you guys can jump to that? Probably, most of you, yes. So, to solve a polynomial equation, get equation equal to 0. Factor completely. This is what we did yesterday. Solve each factor, set it equal to 0. Solve for each value of x, and then write as a set. Oh, I forgot to do that. I probably should have done that right here. So my solutions are write as a set 5, 9. There it is, written as a set. Why? Why, you ask? You probably asked why. Why? Because the only way to multiply to get 0 is something times 0. It's kind of like if you hang around a 0. So like you hang around a 0, and this guy hangs around a 0, and this guy hangs around a 0, and this guy hangs around a 0. This one 0 multiplied by this, then by this, then by this, then by this. Doesn't matter what they are. They're all 0. Guess what happens when you hang around a 0? You become a 0. That's why I tell you every day you leave class, don't hang around losers, because they're just going to bring you down. So, guess what happens if we eliminate the loser? It's no longer 0, and therefore you're no longer a 0. So it's just whatever the product is. But as soon as you add in Mr. Goose Egg, Mr. 0, Mr. I'm not going anywhere, 0, 0, 0, 0, you're all zeros. So stop hanging around losers. They just do nothing but bring you down in life, and they will make you unsuccessful losers. And we don't need any more losers. We got enough losers in the world. All right, kids, enough of the lecture. Let's get going. Let's rock and rolla. Rolla and rocka. Rock it and rolla. Yes, I just finished my 3rd cup of coffee, so I am talking very fast. Now, here's what's going to happen, kids. I'm going to work through these problems. I'm going to work through them rather quickly. You ought to hit that thing called the pause button. It's probably somewhere around there, or maybe it's right here. Or if it's YouTube, you just click somewhere here in the middle, and you can hit pause. Don't watch me perform like a monkey. It's like sitting here going, going to factor, going to solve quadratics, going to solve some equals. Yay. Dude, I'm not a performing monkey. Okay, I'm not going to come around with a little cup and check for money. Although I could use the money. And if you want to hit that subscribe button, you want to hit the donate. The ads make sense. You hit the ads. Maybe you'll buy something. I don't know. I don't really care. What I do care is that you get better at math. All right, stop watching the performing monkey. Pretend I'm going like this. Well, that's like not a monkey, but whatever. So anyway, here we go. We're going to get started. We've got a four-nomial. Polynomial. That's funny, Mr. Krause. I know it's called a polynomial. I know that. I'm not crazy. But it got 4 things. And so when you got a polynomial, You got to do it by grouping. So we take out an x squared, and I'm left with x plus 6. Minus! Take out a 4, but you took out a minus 4, otherwise known as a negative 4. And because you took out a negative, you have to switch the sign on the inside. Not to mention, I'm not going to tell you this a million times, these have to match. Now those become your first set of parentheses. X plus 6. Now let's pretend you came through and took those out. What's left over? Oh, x squared minus 4. Well, isn't that factorable to x plus 2, x minus 2 equals 0? Don't forget the equal 0, or you will be 1, or that's what your grade will be. And then you'll go home, and your mom will be like, oh, you're a 0. You're not going anywhere. Give me your phone. Oh, you know who I'm talking about. L-I-M-O-N-T-S. Just kidding, kids. Okay, so don't forget to set it equal to 0. Then what we have to do, and I'm going to do this once, but I'm not going to do this again until we get to the harder problem. No, I'm not going to do this. You know that the answer here is x equals negative 6. You know the answer here is x equals negative 2. And you know the answer here is x equals positive 2. Give your answer in set notation. Negative 6, negative 2, 2. There it is. Yay! Now, in order to get some room, I'm going to get rid of my 0. But don't you do that. Of course, you write really humongous. Don't write humongous. We don't have a polynomial here, but we do have a GCF. So you need to take out the GCF. So the GCF in this case is 4. Because you're solving it, you really can just throw it away. I don't need it anymore. But if you want to just leave it around for the fun, that's fine. So I can keep the 4 coming around, or you can just get rid of it. It's not necessary anymore. X squared and x squared. They got to multiply to negative 11 and add up to positive 10. So that's positive 11 and negative 1. Wait a second, Mr. Krause. You told this looks like a difference of perfect squares right here. Oh, yes, it is. Oh, yes, it is. It is. It is. I'm just going to keep doing that. I don't know why. So, guys, this is going to get a little complicated. So I really want you to pay attention. This is x squared plus 11. This one is x plus 1, x minus 1 equals 0. Now, only because this one's going to get a little bit crazy, I'm going to show you some steps. So the step here is to say x plus 1 equals 0, subtract 1, and I get x equals negative 1. The step here is x minus 1 equals 0, add 1, I get x equals 1. Now, I know there's a group of you going, what the is wrong with Mr. Krause? Is he crazy? Why would he do that? I know it's negative 1 and positive 1. I'm not crazy. Okay, I've been teaching for 20 years, so I'm a little cuckoo, but I'm not crazy. I know why I did it. Now, why I did it was because this thing right here. Let me highlight it in yellow because you're going to mess it up if you're not careful with this. This one is a little funky cold Medina, if you know what I'm saying. We're going to set this equal to 0. It's not factorable, but it is solvable because you're in Algebra 2. So we're going to bring the 11 over to the other side. Now, in order to get rid of a square, we take the square root. But you remember, because you have that annoying teacher that says when you take the square root, you have to remember to put a plus or minus. So this gives me x equals plus or minus. What is the square root of this negative? Oh, yeah, I. Can't take the square root of 11, so it's I square roots of 11. So yes, those are two answers. So your answers are really plus or minus I square roots of 11. And just for fun, plus or minus 1. I could write plus 1 and minus 1, but plus or minus 1 helps me out. Be careful, those are going to come. Oh, yeah. Welcome to 11th grade. You now can drive, and you can take the square root of a negative number. They come hand in hand. You don't know how to take the square root of a negative number, you don't get your license. It should be on the test. I'm saying. Just saying. Okay, so first rule in factoring, it's got to be set equal to 0. I had a kid write this the other day. And I'm like, really? Because this should be in the middle. Remember, we want it in standard form. And standard form says, okay, we're going to bring this over. The exponent should be arranged in order. So minus 10x squared plus 9 equals 0. Oh yeah, we got some funky factoring. Hey, double F word, funky factoring. So x squared and x squared, signs are going to be the same and they're both going to be negative. So minus 1 minus 9. Holy mackerel! Got some more factoring to do. I'm going to do this two different ways. Some of you are smart enough to do this. This is x plus 1, x minus 1. This is x plus 3. This is x minus 3. This gives me x equals negative 1. This gives me x equals positive 1. This gives me x equals negative 3. And this gives me x equals negative 3, positive 3. So my three answers are plus and minus 1, plus and minus 3. I don't know why I just wrote another 3. Let me do it a different way. I can just set these equal to 0. X squared minus 1 equals 0. X squared equals 1. Take the square root of both sides. Don't forget to put a plus or minus, and I get x equals plus or minus 1. I could have done it that way. Or I could factor them. X squared equals 9. X equals plus or minus 3, because you're going to take the square root of both sides, right? I don't really care which way you do it. I'm okay. Okay, what we're going to do is we're going to bring this thing over. Now, this is a cube. It's not bigger than a 5, but it is bigger than this 1 here, so it goes in the middle. So 2x to the 5th minus 14x cubed plus 24x equals 0. Now, as you're going through this day, don't forget all the other stuff I taught you, chillin'. You still have to take out the GCF. In this case, the GCF is 2x. Now, I cannot throw this away because it has an x. But clearly, 0 is going to be one of my solutions. Whenever there's a GCF that has an x in it, 0 is going to be one of my solutions. Now, think about it this way. If you put in a 0 here, and a 0 here, and a 0 here, isn't the whole thing going to be just 0? Sure. So I took out my GCF, and I'm left with x to the 4th minus 7x squared plus 12 equals 0. Now I have some more factoring. 2. This is x squared and x squared. Welcome to high school mathematics, where we don't baby you. Signs are going to be the same, and they're both going to be negative. Negative 3 and 4. So at this point, you can either rewrite this as x plus 2, x minus 2, or you can just do the other thing that I did just over to the left. So everything is done being factored. Now I have to solve it. This one over here, this first one's going to give me x equals 0. That's one of my solutions. This one, I'm going to bring the, remember, I'm going to set it equal to 0, bring the 3 over, so I get x squared equals 3, or x equals plus or minus the square root of 3. Now, this time there's no I because I didn't have a negative. And this is x equals 2, negative 2. And this is x equals positive 2. Curly brackets, 0 plus or minus radical 3 plus or minus 2. And I'm okay with plus or minus. It saves time. Woo! We got a polynomial! Oh yeah, baby, polynomial. Got us a polynomial. Mr. Krause, why you talk like that? I don't know. Don't make me mad. We're going to purple. Why purple? I want to. Group. I can take out a x to, I was going x to the 4th. Oh man, this one's going to get funky. Yeah. I have no idea why I'm acting like this. I blame coffee and psychosis. Take out x to the 4th out of this. I'm left with x squared minus 4-bagger. Ooh, that's a perfect squares. Minus 9. Now I took out a negative. That means the sign in this thing has to change. X squared minus 4 equals 0. Now, they have this in common. So I'm going to take that away from both of them. But I like to save myself some time. I know that's x plus 2, x minus 2. So gone, gone. Look what I have left. X to the fourth minus 9. I know that is also the difference of perfect squares. That's x squared plus 3, x squared minus 3 equals 0. Ooh, did I forget to put an equal 0 up here? Oh, shame on me. All right, kids, we're almost done. Nothing else can be factored, but I got some crazy work to do. So this is x equals negative 2. This is x equals positive 2. This one here gives me x squared equals negative 3. Take the square root of both sides and put a plus or minus. So this one gives me x equals plus or minus. Now, because that's negative, that looks like an I. It looks like a little finger. I square roots of 3. This one gives me x squared equals positive 3. I'm just going to take the square root and put a plus or minus, but there's no I here. So I get x equals plus or minus radical 3. Ooh, that's fun. So here's my answer. Plus or minus 2, plus or minus I radical 3, plus or minus radical 3. Ka-ching. Mr. Krause is so much fun. Set it equal to 0 and shut up and get to work, you lousy students. Mr. Krause, you're not very nice to us. We work so hard, and you're not nice to us. Oh, yeah? You want nice? Go to Grandma. You want mean and nasty? Come to me. I have no idea why I'm talking like this. It's like I've been up since 4 o'clock this morning recording. Oh, I have. Take out a GCF. Now, wait a second. 9? Nope, 9 doesn't go into 48. How about 3? 3 goes in. Do you guys remember the divisibility rule for 3? Divisibility rule for 3 says if I add up these digits, and that's divisible by 3, the whole number is divisible by 3. So 48 is in fact divisible by 3, and so we're going to take out a 3x cubed. And I'm left with 16x squared minus 9 equals 0. Well, that's the difference of perfect squares, so I'm going to factor that. 3x cubed. By the way, this is just going to give me 0 as an answer. I don't care if it's cubed or to the 33rd. It's still 0. 4x plus 3 and 4x minus 3 equals 0. So my 3 answers, chillin', are going to be x equals 0, x, now I'll do this one, 4x plus 3 equals 0. I'm tired of doing this. Minus 3, minus 3. So I get 4x equals negative 3, or x equals negative 3 over 4. This one, bring the 3 over, divide by 4, I get x equals 3/4. All right, you guys got to know, 3 goes to the other side, divide by 4. So my 3 answers are 0 and plus or minus 3/4. Oh, Nelly! What do we got here? Let's see. So this is the difference of perfect cubes. So we're going to factor this. Now this is going to factor 2. Let's get the binomial, trinomial, x. Oh, wait. I got to put the signs in. I probably should just think about this, though. I don't want to use that. I don't want to use that. Let's go back to red. This is x cubed, and this is 2 cubed. So, parentheses, parentheses, trinomial. Let's put in our signs. Copy over to sign. Change it. Last one's always positive. The 2 things go here, x and 2. X squared goes here. 2 squared goes here. And then you multiply them, 2x. So this one gives me x equals negative 2. Guess what, kids? That's not factorable. But I can do completing a square on it, so that's what I'm going to do. It's not factorable. I don't know what I just drew there. So I'm going to do completing a square. So x squared minus 2x plus square equals negative 4 plus square. Half of this squared is x minus 1, 1. So I get equals negative 3. this should be squared. Take the square root of both sides. Now notice I've got a negative, so I'm going to have I in it, plus or minus. So I get x minus 1 equals plus or minus the square root of negative 3. And then I'll finish this by bringing the 1 over. So x equals 1 plus or minus I square roots of 3. Oh yeah, you're going to have to do that. So here are my answers. Negative 2, comma, 1 plus or minus I radical 3. Oh, that was so much fun. I almost feel like I just, rather, get punched in the head. Sure, because that would be fun. Believe it or not, this is the difference of perfect cubes. This is 7 cubed, and this is 4 cubed. We're going to go over those cubes again, although Friday's an IB day, so I'm not sure how much work we're going to get done. This is 7x cubed, and this is 4 cubed. So this is binomial, trinomial, copy over the sign, change it, last one's always positive. In the front, we put just the two things, 7x and 4. Then we square it, 49x squared. Now you multiply them, 28x, and now the other one's squared, 16. Holy smokes. This one gives me x equals negative 4 over 7. This one gives me a pain in my derriere. Derriere is like an official old man term. So while that's booting up, I'm going to get... There's no way we're doing completing the square on this, because the first step in completing the square would be to divide by 49. That ain't going to happen. So we're going to write a equals 49. B equals negative 28, C equals 16, and D is equal to B squared minus 4AC. I don't think I'd ever ask you one this hard on a test, but just for fun, let's do it. B squared, I have no idea what 28 squared is. Where's my calculator? There it is. So I don't need that. You can go away now. So, go away. 28 squared. Yes, I know it's negative 28, but, oh my gosh. Calculator. 28 squared. Doesn't matter if I square 28 or square negative 28. It's still going to be 784. So, 784 minus 4 times 49 times 16. Minus 4 times 49 times 16. I bet this is negative. Negative 2352. So x equals negative b, which is positive 28, over 2 times 49 plus or minus the square root of negative 2352 over 2 times 49. Let's see if we can find a perfect square that goes into 52. That I know it's divisible by 4. So now I know it's divisible by 16. And that's divisible by 49. So 16 times 49. So negative 3. Holy crap. Are you kidding me? And what is 16 times 49? Never would I ask you to do a problem like this. So the largest perfect square that goes into both of these is 784. So this is equal to x equals 28 over 98 plus or minus 28i square roots of 3 over 98. Holy crap. I'm done. All right, that's it. That'd be a bonus. That'll be a bonus. Now let's talk about it graphically, and then we'll be done. Again, 2 real roots. Now remember, this is a square. This is a squared term. This has a double root because there's a root, and then notice these are the same, so it bounces off. But because it's a cubic, there's going to be 3 roots. In this case, it's a double root. And in this case, I should have 4 roots. 0, positive 4. But this is going to give me plus or minus I square roots of 3, but they're just imaginary roots because it's not crossing the x-axis. It should cross 4 times. 1, 2, 3, 4, but it doesn't. So 2 of those roots have to be imaginary. So we're going to sketch this based on n behavior, y-intercept, and its roots. So the first thing we're going to do is factor it. X squared minus 1, x plus 1, x minus 1. So let me blow this up a little bit so you can see it better. I think that's good enough. And what we're going to do is we're going to plot those roots. So my roots are 0, negative 1. Oh, my roots are x equals 0, x equals negative 1, and x equals positive 1. 1. Let's make 1 going over 2. Just that'll confuse you. I don't want to confuse you. Some of you are easily confused. So we'll just make it a going over 1. Negative 1 and positive 1. So the y-intercept is the origin. I apologize, I'm off screen. The y-intercept is the origin, so it's going to go through the origin. It's an odd one, so if I think about an odd one, it's going to go up the whole time, right? Because isn't this, well, it's got to go off the screen. It's got to go up and down, but because the leading coefficient is positive, it has to go generally in that direction. So off to the left, I'm going to start. Let's do this in blue. Off to the left, I'm going to start down. Off to the right, I'm eventually going to go up. So what I'm going to do is come across, go back down, and come back up. And notice I've got an odd going off to the left, up to the right. That makes it positive, and it's a cubic. Good, we're done. Oops, can't see this one too much. Let me unblow this up so I can see what's going on here. All right, so we're going to do this one based on n behavior, y-intercept. So the y-intercept, let's think about this. First of all, it is going to be a 4th degree polynomial. This is going to get multiplied by this, is going to get multiplied by this, is going to get multiplied by this. Agreed? So it's going to be a 4th degree polynomial. The y-intercept is going to be these things multiplied together. So that's 2 times 2 times 2 times 2, which is 16. So I'm going to have to change the scale on this a little bit. Now, wait a second. What do I have here? Really what I have here is x plus 2 squared. So I got like a quadruple root. There's only one place it's going to hit. It's going to hit at x equals negative 2. So the only place this thing's going to hit is here. And believe it or not, it's just going to look like, and it's going to go through 16 up there. You know, and if you don't believe me, let's graph it. Let's get rid of that. And x plus 2. I don't want to have to write all this out, so I'm going to raise it to the 4th power because that's all that means. There it is. And it's going through y equals 16. You don't believe me? Let's just... There it is, right there, about 16. It's crossing over. So that's it, kids. All she wrote. That was an easy one. All right, let's take a look at this one. It is a 1, 2, 3, 4, 5th degree polynomial. So x to the 5th. It's going to have 5 roots. 1, 2, negative 3, at negative 4, it's a double root, which means it's going to bounce off. So because this is a double root, that means it's going to bounce off. Now, I don't know if it's going to bounce off this way or it's going to bounce off this way. But notice here, it's a odd exponent. Wait, 1, 2, 3, 4, 5. I said x to the 5th and I wrote x to the 4th. So I apologize. It's an odd exponent. So it's should have 5 roots. So that means it's going to start coming from down here. Now, because this one is the double root, it's going to bounce off. And then it's going to go back up. And then it's going to go back down. wait, I should know the y-intercept. So let me think about what I know for the y-intercept. I should figure that out first. Let me pretend like I didn't write that. The y-intercept is going to come from multiplying these numbers together. So in this case, the y-intercept is ginormous. 4 times 4 is 16, times 3 is 48, times 2 is 98. And it is going to be positive, 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 and 2 negative. So it's negative times negative, which is positive times positive. So it's going to be positive 98. So that means I'm going to make my scale on my boxes 1 to the left and right, but 10 up and down. And the reason I'm going to make it 10 up and down is because 98 is going to be right about there then. So as I come up, here's how it's going to look. It's going to bounce off here. I don't really care what that looks like. It's going to go way up here. It is, in fact, going to go through here and back up and this way. Notice it's an odd coefficient, and it's going up in that direction. Let's take a look and see what this looks like graphically. So hit Tab. Go delete this. So this is going to be a pain in the neck to write. So it's x. I can't really see. I don't remember what it was. Minus 1, minus 2, 3, and 4, 4. So x minus 1, x minus 3, right? And then 4, 4. Oh, I forgot the minus 2. No, it's plus 3. Shoot. Minus 2. X plus 3. And the last one I'm just going to write is x plus 4 squared. Notice I told you it was going to bounce off it. Oh, it made these two. So here's what we're going to do. We're going to change the menu. I almost got confused there for a second. And we're going to change the window settings. And we're going to make this negative 10 and 10. And then we're going to make the scale on the y-axis. We're going to go negative 100. Wait, hold on. Do I want to go negative 100? Oh, I forgot what it looked like. Let's go 1. I know I need to get at least 100. 100 wasn't even enough. So let's go window zoom, and make this positive 120. Probably should be enough. Okay. So look what's going on. It's bouncing off at 4, coming back down, popping up, going up. It's crossing at 98, coming back down through, bouncing and going back up. So it's an odd exponent. It's kind of tough. All right, here we go. I think that's it. Oh, we got one more. All right, let's see what we got here. Now, this is going to give me a root at x equals 2, and this is going to give me an x at root at 3. But this is imaginary roots. This is x equals plus or minus I square roots of 1. It's just plus or minus I is really what it is. So I solve that, I'd get x squared equals negative 1, and then I take the square root of both sides, and square root of negative 1 is just I. So it's going to give me two imaginary roots. My y-intercept is going to be positive 1 times negative 2 times negative 3. So my y-intercept is going to be 6. 1, 2, 3, 4, 5, 6. I know it's going to intercept there. I know it's going to intercept at negative 2 and negative 3. I know it's going up because the leading coefficient is positive. So it's going to look something like this. Down, up, and go through there. Let's see how close I was. Tab. Now let's get rid of this because I don't want a crazy. So going back into graph mode, and it was parentheses x squared plus 1 parentheses x plus 2 parentheses x plus 3. It's pretty good. Comes down, goes back up, has a little wiggle, and goes through 6. There it is. That's it, kids. That's all she wrote. That's what I'm looking for tonight's homework. All right, it was a lot of fun playing and working with you. I'm sorry acting so goofy. I just got so excited about math and doing all this math stuff, and I hope you guys do too. All right, kids. Adios. It's been fun, and it's been real, but it hasn't been real fun. Bye.